Can everybody read the rules on the board okay? Okay, now, what you've got on your rule sheet is not only the set of rules that you see on the board, but also a set of rules that you're going to get in Chapter 8. So when you see the arrow, the one-way arrow, and you see the two-way arrow, just ignore those guys for right now. Normally I give you the rule sheets piecemeal, but again, trying to save paper, so I'm giving them to you all at once. The rule sheet is like your security blanket. You're going to be such rock stars with the rules, you won't need the rule sheet, but you're going to have it. You'll sleep with it under your pillow. It's going to be awesome, right? The rule sheets are there to make sure that you can just consult to confirm what you already know, okay? All right, so first off, so I'll ask the same question that I was asking the 930 group. Do you remember us discussing these rules? Okay, so you remember us discussing them. What's your response right now? When you look at these, are you saying, yeah, I remember we talked about them, but I don't remember what they mean, and I sure as heck don't remember how I'm supposed to use them, because we only just started using them, right? So it's not like I expect you to know always how to use each of the rules. So what's your thinking on these? Tell me what's happening for you right now. What's your experience? What's your mental life right now? There's no right answer. How many of you are thinking about something else? You're like, yeah, block. I'm going to go think about something else. How many of you are thinking about this stuff and you're saying, I see the symbols, I understand some of what those symbols mean, but I really don't know what I'm looking at. It's kind of like reading something and you don't understand what you're reading. Anybody having that feeling? Okay, yeah, again, totally normal. So here's what we want to do, right? Remember, you want to pay attention to how you're feeling mentally, because if you're not paying attention to it, it might push you in directions that you don't quite want to go. So you've said, hey, my block is, I know what I'm looking at, but I don't know what it means. Let's review, because you just don't remember. Which, by the way, reminds me, this is the point where you want to keep drilling a little bit every day, right? Doesn't matter if it's 10 minutes, 20 minutes, an hour, whatever you can devote. I wouldn't devote tons of time, especially if you're having a problem, right? So for example, somebody came in this morning to office hour and said, hey, I got to this point in the homework, I couldn't figure out what to do, let's talk. Perfect, that's exactly what, work it, worry it a bit, but if it doesn't yield to you, put it away, come back to it later. Put it away, come see me, come see Harut, come see Lindsay, whoever it is that'll help you. Okay, so let's start with a quick review of what I think is our easiest way of thinking about stuff. We know what makes a conjunction true, correct? We know what makes a disjunction true. And we know what a contradiction is. Okay? All right, so let's back up. What makes a conjunction true? A conjunction is true when and only when? When and only when each of the conjuncts is true. So I have some sentence, P. I have some sentence, Q. The dots just mean I'm somewhere in my proof. Could be I'm in the premises, could be I've derived steps, doesn't matter. I've got P, I've got Q, therefore I have P and Q. I've got P and Q, therefore I have P and Q, therefore I have Q. You have whatever you want to move forward in the proof. And that'll become clear as we go, right? So these rules are truth definition rules. What do we think? Does this ring some bells? Okay, next. What makes a disjunction true? When at least one of the disjuncts is true, exactly. So if I have P, I have P or Q. If Jason is wearing a K-Rock cap, if it's true that Jason is wearing a K-Rock cap, it's true that Jason or somebody else is. Yeah? So, disjunction intro. Disjunction elimination, a little bit more complicated, and yet we understand the truth table, right? I'm told that P or Q is true. It could be the case that P is true and Q is true. It could be the case that P is true, Q is false. It could be the case that P is false, Q is true. I'm just told that it is true. I don't know how it's true. So since I don't know how it's true, I'm going to say, well, let me just assume that I have P. Let's assume it's true. What follows from that? S. What's S? What I want. Now let's assume that I have Q. If Q is true, it follows I have S. Why S? Because that's what I want, right? So in either case, I have S. Now, remember we talked about this. I gave you an obnoxious example, not because this is a class on political disagreements, but because obnoxiousness sometimes stays with us, right? Do you remember what the example was? Trump. Rom's just like Trump. Okay, what do you remember more? What was the example about Trump? Yeah, those are kinder terms than I use. Yeah, so the argument, we'll use Romton's terms because they're kinder than, right? So I read this article. It was more of an opinion piece, right? An opinion piece in which somebody argued, look, Trump is either a maniac or an imbecile, but in either case we're screwed, right? So Trump's either a maniac or an imbecile. In either case we're screwed, right? Let's assume he's a maniac. If he's a maniac, he's going to do some really horrible stuff, and so we're screwed. Now let's assume that he's an imbecile. If he's an imbecile, he's going to make some really bad decisions, and so we're screwed. So in either case, we're screwed. The nicer example, remember I read it from the textbook, right, about whether or not to rush back to the meter that we are confident has expired, right? So what we've got here is simply, this is the formal version. It's called disjunction elimination, but informally it's called proof by cases, right? I don't know which side of my disjunction is true. It could be the case that each side is true. So what I have to do in order to get to my conclusion is I have to assume one side and then the other. Which brings us to a review of our subproof, right? So remember that our vertical line represents in this case, the main sequence, right? We're given a disjunction. Whenever we indent and make another assumption, that is an assumption that is not the premises. Those are themselves assumptions. But we make a further assumption, right? So we've got somewhere in our proof, or maybe P or Q is one of the premises. This is, let's further assume. That's what that indented sequence is. It's an assumptive proof, a subproof. And then we have another subproof in terms of negation intro. This is typically the rule that is for most of us the most counterintuitive, so we want to maybe revisit it. But this is what it looks like. Right? So when you want to create a negation, you assume that the negated sentence is false, right? So you assume the opposite. From that, you generate a contradiction. Remember, we talked a bit about what this symbol means. We'll talk more about it today. So that from that contradiction, we get out of the assumptive proof and we say, from this assumption, we derived a necessarily false sentence, which means this assumption is not the case. And then lastly, we know that truth functionally, again, two negations yield an affirmative sentence. All right, so now we just did that fast and dirty review. Now what are you thinking? Which do you find to be the most mentally comfortable? What's the best fit for you? Give me one or two rules that you go, yeah, I really, when I look at this rule, I go, yeah, I got it. Go ahead. I'm assuming that at least one of them is comfortable. What do you think? Okay, Natalia likes Negation Elim. Good for you. So whenever you see a double negation, you can eliminate it. Okay, that's a tactic. What else? Come on, find one you like. Or maybe think about it as like an adoption fair. Find a rule to adopt, and then you'll love that rule.
Negation intro is good.
Okay, Romton likes negation intro. Now so negation intro, like I said, it's kind of like the the elderly pit bull nobody wants to adopt, right? But it turns out to be this amazingly wonderful rule. We need to talk about it more. Why do you like this rule?
It's just common
It's
sense, right?
just common sense. Elizabeth's nodding her head. So you find this an attractive and appealing, a mentally attractive, mentally appealing rule. When you guys say makes sense, can you articulate what you're thinking?
Right. Well, I mean, if you have not P, you assume P, and you get a contradiction. Well, of course it's not P, right?
Okay. Now, question for you. Do you transfer that notion over to an example we worked on Thursday? I use the same example over and over again for at least one reason, which is the more you see this, the more familiar it is to you, the more likely it's going to be that you say, at least I understand what's happening here with this example. Maybe as time goes on, I think it's going to be the case that you understand what it means and you can apply it sort of crab walk to other arguments. What do we know about a valid argument? A valid argument is one in which if the premises are true, it's impossible for the conclusion to be false. All right, beautiful. So, do you remember this guy? Right? Candy. Yeah. Candy's in one hand or the other. It's not in one, so it's got to be in the other. And if it turns out that it's not in the other, it means which means I contradicted one of my. All right. Let's look at this in terms of truth functionality. Okay, valid argument. I don't believe you're valid. I'm going to assume, not with that color marker, I'm going to assume you're invalid. Yes? Right, I'm going to assume, and remember this, so premise 1, premise 2, conclusion. I'm going to assume that the premises are true and the conclusion is false. Okay, now let's backfill. And there are two ways we can do this. If Q is false, I plug it in up here. If Q is false, but I'm saying that the disjunction is true, what must P be? True. I plug it in over here and, oh no, as Connor says, I have generated a contradiction that is not P must be false if P is true, right? So the moment you generate a contradiction, you're told, and it's a truth it's a truth table contradiction. It is a truth functional contradiction. It's a truth definition contradiction. In other words, I've contradicted the definition of negation, which means that Q must be okay. Let's do this one more time. Let's generate the contradiction one more place, and then we're going to go back over to negation intro. All right, here I go again. Q is false, not P is true. P or Q is true. And now I'm going to start with not P. If not P is true, P must be false. I'm going to plug that in over here. I've got P false. What is Q? Oh no! Right? I contradicted the definition of disjunction. Okay, so first, am I correct that there's no worry over the truth definitions? Am I correct that there's no worry over why we can't maintain true premises and a false conclusion? And if you're saying, I know that you're saying it, Mia. I mean, I know what it means for you to say that this is happening, but I haven't really grasped it yet. Kevin, what are you thinking? Sure.
Does this only happen when it's not a tautological consequence? Or is there other cases when it's not true, false?
I got discombobulated. We generate a contradiction when the sentence is a tautological consequence, but we treat it as though it's not.
Oh, I see. Okay. That makes sense.
Yeah? How can you, sorry, a couple people are nodding. Jump in. How do you articulate Kevin's great question? Right? So Q is a taut con of premise 1 and premise 2. We can generate an invalid argument, a sentence that's not a taut con, but then we wouldn't be able to use our rules with it, right? We wouldn't be able to generate a rule out of it. How might you want to articulate what we've just done here? What do we think? We know what our truth definitions are. We know how we've generated a contradiction. So now, come back over here. Here's my conclusion. As Ramtin points out earlier, I assume my conclusion is false. I generate a contradiction. That is, in some versions of the system, right? This sentence, P conjunction not P, is a self-contradictory sentence, right? So somewhere in your proof, right, you've got sentences that are contradictories, which then means that the assumption can't be true, which means you introduce the negation. Better? Now, sorry, Connor, what are you thinking?
Can you write that out right there, what we have, in the form of like a fit?
Yeah.
Consequence.
Yeah. Now, okay. So I'm going to restate what Connor wants us to do in just a moment to make sure we're all clear on this. But just as a quick aside, in some versions of the system we're learning, we're given this as a rule. It's called Disjunctive Syllogism. It's actually a combo deal of Negation Intro and Disjunction Elim. So hold on to that. First, is everybody okay with me erasing what's on the board? Or sorry, in the middle board? Yeah? Okay. All right, so you just used an indirect method to show that the argument is valid. More specifically, you just use the indirect truth table. Negation intro is sometimes called indirect proof. Okay? It's the formal version of what's known as a reductio ad absurdum, a reduction to an absurdity, where an absurdity is a logical contradiction. Here we're talking truth functional contradiction. There are two types of contradiction that we're going to look at, but so just hold on to that. That's why I'm using that specific language. That is, I'm saying a truth functional contradiction. So in some versions of the system, you're given what's known as disjunctive syllogism as a rule to move forward in a proof. Okay? Notice what we've got. Either I have candy in my left hand or my right hand. Yeah? Here's the contradiction, right? That dismantles the disjunction. So there's a sense in which, right, you could say disjunctive syllogism is a combo deal of eliminating the disjunction by means of a contradiction. We're not going to use this as a rule. We're going to freaking prove it. And we did. We actually did on Thursday. But this is another reason why, and I'm so glad that you mentioned this, Connor. This is another reason why repetition isn't a bad idea, right? Seeing things, the same things over and over again, then allows you to start seeing the form in different contexts. And that's going to, I hope, become clear as we go forward. So let's do this. Here's our argument. Premise 1, P or Q. Premise 2, not P. And what we want is Q. Strategy time. Let's take negation intro, right? We just discussed this. It's the rule that a number of you go, yeah, I love it. Okay? Strategy time. When your conclusion, I'll give you a strategy sheet, but just bear this in mind. When your conclusion is an atomic sentence or a negation of an atomic sentence, it's called a literal, use negation intro, right? Structure your proof according to negation intro. Heck, you can use negation intro for any valid argument. It's just that in some cases, it might take you longer to get to where you want to go. Right? So it's not like it's inappropriate to use negation intro for other valid arguments. Again, it just might take you longer than a different strategy. All right, so here's what we do. At line 3, we're going to assume Q is false, generate a contradiction so that we get out and we introduce a negation. Now, since I already have a negation at the assumptive step, I introduce a second negation. Fitch will not force you when you get out to say not Q. It'll allow you to go straight to Q. But let's take these detailed steps. Remember, the project we're working on is this. When we are told that an argument is valid, and maybe we test the argument to make sure for ourselves it's valid, and we confirm the argument is valid, we then are in the business of demonstrating how you get from here to here. And remember what we said, it's not sitting in a cafe, smoking a cigarette and wearing a beret and pondering the meaning of life. It's what? Assembling and disassembling sentences, right? Although you can still do it when you're wearing a beret, but I don't recommend the smoking part. Coffee, yes, absolutely. You can ponder the meaning of life while you're doing this. Maybe this is the meaning of life. Or it's 42 if you're a Douglas Adams fan. Okay, next question. Is there an implicit contradiction? Sure, there are two, right? I've assumed not Q, and I have been given, there's another assumption, not P, and I have my disjunction, contradiction here, right? What else do I know? So here's another strategy. When you have a disjunction, what do you do with it?
You assume.
Yeah, you eliminate it by way of assuming each side and getting what you want. So here's how you can start to think about your rules. You look at what you're given, you look at where you want to go, and then you ask what rules are relevant, right? We're going to be working strategically. Remember, we talked about going to Hollywood for a movie. Didn't we talk about that? Yeah. And if we want to get to, a 7:30 p.m. show and we're in Woodland Hills, back time it, right? We work from our conclusion. Right, so as Ramtin points out, we've got the disjunction. So we're going to. Oh, this is terrible. So we're going to assume P. What do we want? A contradiction. Yeah. Assume Q. What do we want? So that we can say in either case, I have a contradiction. Isn't that awesome? Don't let me forget to give this back to you. So before we move on to details, am I correct to say that when we see in the rule form S, that's just any old sentence in the universe, including a contradiction, right? So remember here, this contradiction is P and not P. This contradiction is Q and not Q. Okay? All right, so line 4 is an assumption. Line 5 is the contradiction. Line 5 comes from lines what and what? Where do we get this contradiction?
2 and 4.
Yep, 2 and 4, contradiction intro. Now you might say, wait a minute, Mia. I don't know any rule known as contradiction intro. You do, you just don't know you do. And then Connor's saying, look, he's pointing at the sheet. He's holding the sheet up and pointing at it. We're gonna talk about this rule in just a second. We'll put it up on the board. But first, right, 2 and 4 are contradictories. Okay. Now, per the rule, right, from the assumption of one side of the disjunction, we've got the sentence we want. From the assumption of the other side, we're going to get what we want. Why do we want a contradiction? Hold on to that question. We're going to come back to it. Okay. Line 6, assume Q. We get a contradiction at line 7 from lines 3 and 6. Again, contradiction intro. Now, question I just asked you, why did we generate a contradiction? Well, here's again what we're talking about when we're talking about strategies. Our overarching strategy in red is what? Right? Look at the red. Look at negation intro. Look at the red. Look at negation intro. Look at the red. Look at back and forth, back and forth. Now, what is the conclusion of this structuring subproof? So this conclusion becomes the goal of the nested subproof sequence. P.S. How many people are unhappy right now? Anybody unhappy? Okay, what's the class mantra? If Mia can do it, anyone can do it. Okay, so what I'm going to want to know from you guys who are kind enough to share, I'm not happy right now. What I'm going to want you to do is, if you're willing, explain a little bit about what's bothering you. So think about that, and then we're going to talk about it. All right, so now, isn't it the case that from lines 1, 4 through, no, actually, you know what, I should do this in black just because we were talking about the Disjunction Elim. 1, 4 to 5 6 to 7. By disjunction elimination, we have the contradiction. Yes? At line 9, from 3 to 8, negation intro. And Natalia, this is all you. From 9 to 10, right? What is it? Negation elim. Right? Meticulous, step by step, right? Tedious even. Okay, now, how many of you have the following experience? And I think, and Ramton and Elizabeth, based on how you reacted initially to negation intro, I think this fits you, but tell me if I'm wrong. You kind of see the whole. All the pieces fit. And it's not so much that you're seeing it at a granular level, but when it's time for granular, you get there. You're just seeing the whole all at once. Yeah? Matthew, you say? Okay, lovely, good. Now, how many of you say, I don't see the whole all at once, but I'm following as we're doing it? Do we have anybody feeling that way? I don't see the whole all at once, but I am following it. Okay, so Miguel, all right. Now, am I right now to think that the rest of you are saying, bzzz, just a blooming, buzzing confusion? And a couple of people are nodding yeah. So it kind of doesn't matter what camp you fall into, right? What matters is that if you're in the first camp, you say, I can articulate this. Why? Because if you see the big picture, especially as the proofs get longer, but then you're having trouble filling in the gaps, then you get stuck, right? Those of you who are seeing things as we go, your goal is going to be to start to try to think in advance, sort of think strategically, which is what the subproofs do for us. They set up a strategy. And those of you who are feeling the blooming, buzzing confusion, what you're going to want to do is kind of a combo deal in a sense of the first two groups. I'm going to ask you to think about the process of learning the rules and their implementation in something like the following way. When you first got to Pierce, you didn't know where anything was, right? And you probably had a hard time orienting yourself, right? You probably were asking for directions, and then you started looking as you were going to your classes or wherever you were going, you started looking for like signposts, right? So this building means that I do this, and that building means I do that. Or I see the Brahma bowl, and right? So now you're starting to orient your thinking according to certain signposts. Eventually, you got to the point where you don't think about all the distractors, right? So let's say the botanical gardens just don't have anything to do with your class activities, right? You don't walk through the botanical gardens to go where you need to go. So you don't even think about it. You're off doing something else, right? You don't even probably think about the bookstore anymore because you don't need that to orient your thinking. You now have the mental map of where you need to go, right? So you're detailing and you're big picturing. Detailing and big picturing. That's what we're going to map to the work that we're doing here, okay? So it's going to be a lot of drilling, and it will start to yield. Okay. What do we think? Strategy. Whenever you have a negation or you have an atomic sentence, negation intro. Whenever you have a disjunction, eliminate. Those are your two strategies. How are we doing? So far, so good? Are we ready to talk about the contradiction rule? Okay, but here's what we can do. We may not be able right yet to eradicate dread diseases, but we can talk more about the contradiction symbol. Did you like that segue? Did that work? Okay, so are you guys comfortable with the following? So let me write the rules and then we'll talk about them. So contradiction intro and contradiction elim. So here's the rule. Yeah? Now, here's the other rule. You might say, what? But hold on. Or, alternatively, you could do this. Okay, first, the introduction of a contradiction. Remember that this symbol means that I am asserting a contradiction obtains in the sequence. And then the elim rule says from, and we need to talk about why, but from a contradiction, anything follows. Okay, now, thank you, Rumton. I think I should be okay.
Always I'll leave it here.
Okay, just in case. Okay. So, are we? Can you read this? Okay. Now, there are two ways that we will be asserting contradictions. In fact, we've done the first way already previously. But hold on, I'll put it on the board. So, when you use the rule contradiction intro, what you're doing is you're saying in my proof, a truth functional contradiction has obtained, or a truth table contradiction has obtained. Yes? Okay. But that's not the only way that we get contradictions. So, these are two instances of truth functional contradictions, right? Where the conjunction of P with not P says, this can never be true, this is always false, right? So far, so good? But there's another way that sentences can be contradictory. So we can say, so we have, sorry, I had a bottleneck, a thinking bottleneck. So we have P and not P, which is a self-contradictory sentence from the standpoint of a truth table, right? The truth definitions. Then we have, here's an example. I meant to write just A is large. So then we have an analytic contradiction from the standpoint of the meaning, of the predicates. So I know that even though I was speaking when I was writing, this is pretty illegible. Truth functional contradiction, right? That is self-contradictory from the standpoint of the truth table. So you use contradiction intro as a justification, like when you're using the rules. But you and I both know that we have blocks language possibilities in Tarsi's world, in Boole, in Fitch, where we're using Fitch for derivations. You would not use the contradiction intro rule to cite this contradiction. Why? Because this is not a truth functional contradiction, is it? It's an analytic contradiction. It's a contradiction based on the analysis of the meanings of the predicate small and the predicate large. So what you would do is you would use, in your proof, right, you would do something like this. I'm going to infer the contradiction. I'm going to infer the contradiction. But this is contradiction intro. This would just be an anacon. Does that make sense?
But is an anacon an analytical consequence?
It is. Analytical consequence.
The contradiction being the analytical consequence.
Yes.
Okay.
It's a necessarily false sentence. Okay. What do we think? I know some of you aren't happy, but it's going to be awesome. It is awesome. You just haven't realized it yet. Somebody said today, somebody volunteered. We were working a proof, and I was using capital letters, you know, A, B, C. And then at some point I didn't have B, or I didn't have one of the letters in the proof. And she's like, no, but there's a sequence. You need C. And I said, but C doesn't exist in the premises. And it doesn't exist in the conclusion. She's like, yeah, but you need it because it's a sequence. And then later on she said, I'm just stuck on, I'm having a bad morning, and I can only think about these letters in terms of A, B, C, D, E, right? Okay, so you're having a bad morning. It's okay. It happens. Right? So if this is not happy times for you, if these are not happy times for you, don't worry. You're just having a night. Yeah, it's noon. You're probably ready for lunch. Okay, now one of the most counterintuitive rules for some of us is the contradiction elim. What do you mean from a contradiction anything follows? People feel like once they generate a contradiction, if they're not in a negation intro subproof, right? So there are two things you do once you generate a contradiction. If you're in a negation intro subproof, get out. The other thing you can do once you generate a contradiction, whether you're in a subproof or you're on the main spine, is you can assert whatever you want, right? As soon as you generate a contradiction, you can assert whatever you want. Why? Why? Well, let's go back to a valid argument and the truth table for it. Do you remember what row represented the lying when I said to the little girl, I have candy in one hand or the other?
Fourth.
Third row. Yeah. Okay. Hold on. We're going to make sense of contradiction elim, right? What's wrong? You sure?
Yeah, I'm just thinking.
Okay, does anybody mind if I erase the... Okay, going. So, P or Q, not P, Q, right? And we know that we have the following values, right? Double check. Comfortable? By the way, let's take a really quick moment to pause and remember when we were first learning the truth definitions, and now you're just all, boom, I did that. Easy peasy, right? Look at how far you've come. All right, so, sorry about the ink here. Okay, so, oh, I was wrong. No, you were right. You and I were wrong, Elizabeth. So, Romton, you were right. Elizabeth and I were wrong. It is row 4. That was the row I was lying, right? So, hey, kid, I got candy in my left hand or my right hand. It's not in my left hand, so it's in my right hand. That was the lie, right? On the assumption that the premises are true, the conclusion must be true, right? If the conclusion is false, then one of the premises has got to be false, and that was row 4. So I apologize that I misremembered. Okay, so now let's get back to, well, why is it that from a contradiction anything follows? Well, if we know that on the one row where the premises are true, the conclusion has to be true, right? Then we know that there are other rows, 3 out of 4 rows, where there's some sort of combination of values, right? So if your argument is valid, it is the case that on the assumption your premises are true, your conclusion must be true. But what if you do see that you have a false premise? That means that your conclusion could in fact be false. It means that one of the other premises could in fact be false, right? So once you've generated that contradiction, you can say effectively whatever it is that you want, but typically what you want is going to get you, I mean, not typically, always in a proof, what you want is what's going to get you towards your conclusion. Okay, so don't feel like you're cheating if you assert what you want after a contradiction. Okay, are we ready for some super awesome practice? Okay, here we go. So, remember, you've got your rules in front of you, and you know also what your truth definitions are. Okay, so suppose that we have something like this. A and B, C, and then we want A and C. So what I'm doing is just putting my conclusion off to the right because, you know, I don't know how long it's going to take me to get there. So this is often the way that things are set up. Obviously, when you're working in Fitch, you're given the goal, right, at the bottom. And we can certainly put it here, just to make sure that we don't forget where we're trying to go. Okay, so question for you, does it make sense to say that your conclusion is implicit in the premises? Or your premises are pregnant with the conclusion? The conclusion's in here, it just needs to be extracted, right? So I've got A and I've got C, but they're not together. My job is to put them together, right? So here's how you're going to go. You're going to think strategically. So remember, we right now have 2 strategies. One of which says, when you have a disjunction, what do? Yeah, set up disjunction elimination. So what if I do, I'm putting the green over here just so we can see it. What if I say, okay, I'm going to assume not B, what do I want, A and C. I'm going to assume C, what do I want, A and C, so that I can get out and say, from either side of the disjunction at line 2, I have A and C. How many people go, yeah? How many people go, kind of, yeah, okay. Do you mind articulating what you're thinking, right? How many of you who are going, what's going on for you? What are you thinking, Matthew?
How do we get, like, why do we put A and C twice? Like that?
Oh, great question. Okay, so is it clear that here, starting from line 3, we're setting up a disjunction elimination? And what you're typically going to do is this. Your goal of each of the successive subproofs is going to be the goal of your conclusion. Now, is that always the case? No, but let's act like it is right now. Yeah, great question. What else is going on? How do you guys who are comfortable, how are you thinking about this? What's happening for you? Like, are you thinking, okay, I see a disjunction and I plug in elimination. And then I start working. Or like what's going on? What are you thinking here? And while you're thinking about what you're going to say, what I'm going to do is, what am I doing? Oh, I'm going to run through this, and then we'll talk about it. All right, like, I've got to push things down just a little bit because I always mess up on the board with like wonky lines, so bear with me. Okay. Sorry, I know I just stood in front of the thing while I was writing and making mistakes. Okay, so everybody should see we've got two premises, A conjunction B. Either it's not B or it's C. And then our goal is, our conclusion is A conjunction C. Remember, the argument is valid. So what we're being asked to do is to demonstrate the conclusion, or another way to put it is to show how we get from the premises to the conclusion, right? What are the steps that we take? So we said that because we have a disjunction, we're going to set up disjunction elimination. That's our strategy. That's our structuring subproof sequence. So we assumed not B. What do we want? A and C. The moment we get A and C, we get out of the first subproof and we go to the second. Remember, they're on the same line effectively. They're successive subproofs. Then we assume C, that is the right side of the disjunction. And then what do we want? The same conclusion, A and C. So that at line 10, we're saying, look, we've used disjunction elimination from either side of line 2, along with lines 3 through 6 and 7 through 9. I've just proven my conclusion. Right, so in either case, whether not B is the case or C is the case, I have both A and C. Yeah? Okay. Now let's back up and look at the justifications and citations. So remember, initially I wasn't thinking clearly, or I wasn't thinking efficiently, and I had pulled A down. Didn't need to do that, but why did I pull B down at line 4 from line 1? Why did I do that? Because I want to generate a contradiction. So here's what's happened. Line 4, so remember, this is an assumption. Every time you see the little fitch bar, you know that you're dealing with an assumption. It's either a given or a further assumption that you're making, right? So I pull, by way of contradiction elimination, or conjunction elimination, right? Look at conjunction elim, look at line 1. That's the justification citation for 4. Okay. What's the contradiction, everybody? So contradiction intro, lines 3 and 4. And by the way, as you're using elements, as you're using premises given or derived, maybe check them off, right? So we will use one again, but we've used it once already. Why am I doing this? Well, because you will always use every line either given or derived, right? You won't leave anything. You won't leave anything out. If you do, it's a superfluous step that you didn't need to take. It's not wrong necessarily, but it's not needed. Now, line 6 is a contradiction elimination from line 5. So this is a case of saying, from a contradiction, anything follows. Okay? There are, again, just to reiterate, 2 possible moves you can make once you generate a contradiction. One of them is the elimination move. The other is, you're in a subproof, get out and assert the negation, introduce the negation. Okay? We can talk more about contradiction elimination, kind of what it means beyond what we've said, but just know that it is it's not a cheater. It is a legitimate move for us to make from the standpoint of truth functionality. Okay. Now we will use 6, as you know, within the context of justifying line 10. So now we move on to 7. We've got an assumption. We're going to cite and justify 8. Where did we get 8? And what justifies it? Yeah. Line 8 comes from line 1. And what's the rule? Conjunction elimination. Good. So now what do we do to justify and cite line 9? Conjunction introduction from lines what and what? 7 and 8. Yep. So check, check. And then we've already asserted our justification and cited our line numbers for line 10. Let me make a couple of observations that you know will probably come up again. Notice that you never cite more than 2 lines for a given inference unless you're citing subproof sequences. Then you cite the sequence. So it's always, you know, either a tactic, I'm calling these tactics, or a strategy. So subproofs give you strategic ways of thinking about how you're going to get to where you want to go, right? They structure the thing for you. And notice, here's, so this is more specific to the point about not citing more than 2 lines. Conjunction intro is a 2-line justification, or sorry, rephrase, a 2-line citation. Conjunction elim, 1-line citation. Disjunction intro, 1-line citation. Negation elim, 1-line citation. Contradiction elim, 1-line citation. Negation intro, or sorry, contradiction intro, 2-line citation. Negation intro, disjunction elim are subproof sequence citations. Now, question for you. Does this example make sense as showing what I was talking about a while ago and then earlier today when I said all we're doing is assembling and disassembling sentences, right?